Hello everyone. Assalamu alaikum. I am Dr. Muhammad Mohsen Wakas from KFU IT Rahim Yar Khan. Today, in the topic of remote sensing, we are going to discuss the interaction of electromagnetic energy. As the OSU, as I mentioned, represent the courses I audited in the OSU, Oregon State University, USA. So let's start with the interaction with the surfaces. Recall that in the previous lecture, recall that all as electromagnetic energy reaches Earth's surface, it must be reflected, absorbed, or transmitted. Proportion accounted for by each process depends on the nature of the surface, the wavelength of the energy, and the angle of illumination. Let's look about more in more detail. We discuss the transmission radiation occur when radiation passes through a substance without significant attenuation. Transmittance, transmittance of many material varies greatly with wavelength. Reflection occurs when a ray of light is redirected and strikes a non-transparent surface. Nature of the reflection depends on the size of the surface, irregularities, roughness, or the smoothness in relation to wavelength of the radiation considered. Reflection. For many applications of remote sensing, brightness of surface is best represented as reflectance. Reflectance is the observed brightness over irradiance. Consider leaf versus water. The reflectance in percentage on the Y scale and on the horizontal scale is the wavelength in micrometer. Water has a different reflectance as compared to the vegetation, as it is increasing and decreasing under different wavelength. So actually this trend of reflectance uh, describe the pattern of the vegetation, presence of water or the water bodies when we are going to map land use, land cover, and other parameters. What does this mean? Using camera and other remote sensing instrument, we can observe brightness of objects over a range of wavelengths so that there are numerous points of comparison between brightness of separate objects. A set of such observation or measurements constitutes a spectral response pattern, sometimes called the spectral signature of an object. This is spectral signature of the vegetation with respect to wavelength, how it is reflecting, and the variation, percentage reflectance under different wavelength. Spectral signature of the soil, how it is soil is reflecting under different wavelengths. What does this mean? Everything in nature has its own unique distribution of reflected, emitted, and absorbed radiation. Theoretically, we can use these spectral characteristics to distinguish one thing from another or to obtain information about the shape, size, and other physical and chemical properties. In case of reality, spectra of feature changes both temporally and spatially. Difficult to define unique signature for specific kind of vegetation, can recognize distinctive spectral pattern for vegetated and non-vegetative area and for certain classes of vegetation. Sometimes detect the existence of disease or stress vegetation. Three model for remote sensing. In the simplest form, one recorded the reflection of solar radiation, and second strategy for remote sensing is to record radiation emitted. Active sensor generate their own energy, then record reflection of that energy. Active versus passive sensor. Passive sensors can only take measurement when energy is present. Daytime for reflectance measurements. Naturally emitted can be detected during day, need large energy source. It is has a cloud has a greater impact on the passive sensor, or cloud distort the image. In case of active sensor, ability to obtain measurements anytime, regardless of time, day, or season, penetrates clouds. Better control for a way a target is illuminated requires generation of fairly large amount of energy. Oldies but goodies resolution. Many type of consider in remote sensing, data, spectral, radiometric, and temporal. Spatial resolution is best described by the size of an image pixel. Correcting image. Geometric distortion. Images are distorted for a number of reasons and require correction before it can be georeferenced or rectified. Mostly this type of rectification is performed by the remote sensing data provider, like the US GS department and other. Spectral and radiometric resolution. Spectral and radiometric resolution depends on the type of instrument and may be related to imagery, that is panchromatic, multispectral, or hyperspectral. A note on images. Here the Landsat thematic mapper color composite image is presented. Bands 3 to 1 RGB bands and band 4 3 to RGB composite image. There are 7 bands in the Landsat image. A note on image. Landsat color composite image band 543 RGB, band 432 RGB image. So the reflectance with one band is presented on the left side and three bands presented on the right side. The green color, the green vegetation, and sun secant vegetation with the gray color. And the pattern of reflectance is how it is reflected with one band and three band is clearly described here in the pictorial way. In case of bits resolution, one bright area, in case one picture was taken on a bright area and a dark area. So in case of 2040 40 and 256, the image is much more clear in 2040, while the if we just took this part, the standing cars or vehicles are not well presented in this right side image. Thank you very much. If you have any question, you can ask me through the system we have on online during online classes.